Okay, good morning. So what we are going to do today in this class is the online class for Matlab for Economics and Finance, summer 2021. Okay, let's start and let's continue with the previous class where we learned how to handle arrays, how to address positions of arrays, how to do some basic arithmetic and linear algebra operations with using Matlab. Okay. Now what we are going to do is we're going to continue working on this, but now we're going to start talking about something that is called the 3D arrays. So remember, if we have a 2D array, it's basically what we call a matrix. So remember this, a 2D array is simply a matrix. And a matrix, as you know, has two dimensions, okay? Has number of rows, let's call it n, and number of columns, let's call it m, right? So, and then you simply have values here, as we have what we have seen before. In a 3D array, we have an additional dimension. So my 3D array is going to be simply a collection of matrices, okay? So we're going to have one matrix. I will draw this as a matrix. Again, I have n times m, but I will not have only one matrix. So I will have faces of matrix. So there's going to be another matrix, same dimension, that also is going to be n times m. And then you can have as many matrices as you want. So we have an additional dimension that let's call this p. So basically an array will be defined as n, m, p. Okay, so remember this represents rows, columns, and let's say this one faces. Yeah, and it's very useful. As you're going to see, you can store data in a much better way. You can perform analysis in a much better way. So let's do, for example, let's create one example and let's start working with this example. Now, let's create perhaps a data that is going to look like panel data. So let's assume that we have my rows represents year. So it will have 5 years. I'm sorry, E4, year 5. So I have 5 years of observations. And then I have 3 individuals, individual 1, individual 2, and individual 3. And then what I do is I simply store what is my income of individual 1 at a time. So the first, so let me do this. So the first matrix is going to be about income. And the second one has the same dimensions, has the same characteristics. It's basically going to have savings. Yeah, we just create some numbers just to create an example. Okay, so let's assume, guys, that and then we are going to start working with this. Let me create some data here. Let's go to Matlab and let's create some data. Okay, so we can this one. So let's create this one here. So let's call my file, my array is going to be called panel data. This is fill all rows, all columns, and this data corresponds to the first phase. So this is my income. So this is going to be the income for year 1, individual 1, 2, and 3, income for individual 2, individual 1, year 2, etc. Right? So this is going to be my income, my first phase. My second phase, what corresponds to savings, is going to be basically this data here. Right? So this is second phase, and this is the savings of each individual per year. If we want to see the complete array, we simply type the name without the semicolon. Oh, panel data. Sorry, it is panel data, not panel array. Here's what we have. So remember, rows are years, columns are individuals. the first phase corresponds to income, the second phase corresponds to savings. So this one here, for example, corresponds to income year number 2 for individual number 2. This one here, you read income for year number 5 for individual number 3. Right? And the same you read here in the second phase, but the second phase, according to my example, is savings. So for example, this corresponds to the saving of individual 2 for year number 1. This one corresponds to savings of individual number 3 for year number 3, and so on. Right? So we can start working with this, and then the first thing that we need to start working is, okay, so for example, I'm interested only about learning what is the income of individual number 1. Okay, so remember that if you want to do a comment in Matlab, you simply do the percentage sign, and I will simply write whatever you want. This is not going to be an execution, so simply words. I want income of individual 1, all years. So this is what I'm trying to have here. Okay, so how do I do that? What I need to do is simply, let's collect this one here. You need to know where is the income. Income corresponds to the first phase, and I want all the income for all years for individual 1. So I'm just considering gross is all years, that's correct. I want that, and I just want individual 1. So what I want, I'm going to select this column number 1. So this corresponds to income of individual 1 for all years. You can do the same if you don't want to see income. Perhaps you want to see the savings of individual 1 for all years. So in this case, this is going to be panel data is the second phase. So, and then you have it. And then perhaps you want to create, guys, a matrix now with the income and savings of individual 1 in a matrix form. So I want the 5 times 2. So let's do income and savings for individual 1 all years. Okay, so what I can create is, let's call this income savings individual 1. Okay, so this is going to be a matrix. And from the matrix, guys, what I will select is basically, I want to put these two things together, one next to the other one. So that's why I need to use the comma, right? So this is going to put my income, and this is going to provide me with a savings. So you have income in the all the years for individual 1. This phase 1 is income. All the years for individual 1 savings, and then you can. I'm sorry. Here we go. Makes sense? So this is a way you can transform an array, a 3D array, into a 2D array, for example. Okay. Now, if we go more specific, I want to know, for example, let's call this X. Okay. So I want to know what is the salary of individual 3 in year 4, for example. So this is going to be my data is here. I can copy all this, and then we can simply replace the values. So what I want is, I will put my comment here, income individual 3 year 4. Okay, that's what I want. So remember, income is represented in phase 1, so this is okay. Individual 3 is the third column, and I just want year 4. So what I want here is position 4, because that corresponds to year 4. And here's what we get. Make sense? Okay, so now, for example, I want to just have as another variable, let's call x1, and that just contains the income. So I want the income of individuals 1 and individual 2 all years. So that's what I want. So I will copy this part here. So the way you address this matrix is exactly the same. So income is 1. I want individuals, I want all years. So that's why I need to use two points. But I just want the information from individuals 1 and 3. Sorry, 1 and 2. So what I can do is 1 2 or 1,2 is the same. Let's do something more. 1 and 2 is too easy. So let's do 1 and 3. So in this case, what we do is 1,3. So I want you to select Matlab to select columns 1 and 3 and give me the first phase that represents the income. So here's where we go. Right? So we have the income of individual 1 and individual 3 during all these years. Make sense? Now, just for practicing, normally don't do this, but imagine now that I want to shift the position. So let me write again panel data just to remember what we have. So this is my panel data. Okay. So now imagine, guys, that I want from both. I want to shift the individual number 3 to be individual number 1, and then the remaining part stays the same. Right? So what we can do is, okay, let's do an X2. Again, we copy our panel. Let's copy this one here. And what I want is now, all the years, I will not change the years. The only thing that I will change is simply the position. So for example, here I want this to be 3, then the second, then the first. Of course, we know how to do this in a different way. We'll do that also. And I want everything, because I don't want just to change the first one, the income. I want to change everything. If I change income in one column, in one phase, I want to change also the saving. So then we have it. You see? So my individual, I have changed. So this corresponds basically to the individual number 3 now. This is individual number 2, and this is individual number 1. So let's take a look. You see, individual 1, 2, and 3. So we have done that. There is another way of doing the same stuff. Instead of using 3, 2, 1, well, remember what we have done is, okay, so we can have a sequence 3 minus 1 to 1. Okay, so we can do that the same. Or if you prefer, instead of using 3, just to make this more flexible program, you can do end. Make sense? Etc. Right, so what we have done in class before is also useful in here. Now, perhaps what we can do is let's do an X3. And what I want from X3 is simply, you know, the saving ratio for all individuals, all years. Okay. So what I want is to create a ratio now. So it's basically the savings divided by the income for all individuals. So I want panel data. Let me do this. All of them. I want the income to go on the top. And remember, I need to use the dot division because it's going to be element by element division. Right? So this represents the savings. And I want to divide this here. And I want to divide this by the income of individuals. And then you get your ratios. So you see, individual number 1, that is the one that makes more money. So I start saving 35%, 47, and then he ends up with 83% of his money saved. Versus the one that is making almost no money. In time, you know, assume that this is adjusted by inflation. In time, he's able to save only 15%, 47% and 83%. Right? So this is of course data that comes only that has been created by me. Nothing, no real data here. One thing that we need to know also, guys, is that remember the size command. So now, if I want to see, if I write size panel data, I will have 3 dimensions. I have 5 rows, 3 columns, 2 phases. If I want to see the total number of observations, remember what we do is plot of size panel data. So this is what we have. So we have 30 observations in total, etc. Make sense? Okay. So I think that we can stop here for a minute. Okay, what we have, so now we have understood how to do 3D arrays, how to address the partitions of the array, etc. So now let's do a little more in terms of finance. Okay, I will do just a brief description of what is coming next. This is not intended to be a full class on finance, okay, or at least in project management. But let's talk a little bit about cash flows. Now let's talk a little about net present values, net future values. Okay, this is something that we are going to be doing. So now, guys, what is a cash flow? Cash flows simply represent outflows and inflows of money in time. Right? So the basic components of cash flows are the following. So we normally have an outflow. So money is getting out, you invest. And then you have inflows, so you receive money. And of course, you have the time dimension here. And there is something more that you don't see directly here, but is the interest rate, what I call I. Okay, so this I is simply the interest rate. And technically, is the interest rate that makes the inflows. Well, let's call CF just to be generic, and let's call this C0. That makes CF equivalent to C0. Okay. So what is equivalent means that the present value of the future value CF is exactly the same as the present value of C0. Right? So this is equivalent. So in finance, guys, when you have equivalent monies, you can sum them, you can subtract them, you can multiply them, etc. But you need to have them all together in the same period of time. Right? This particular cash flow, as soon as you invest first and then you receive the fruits of your investment in the future, this is called an investment cash flow. Then if it's an investment cash flow, there are other cash flows like this one. So you first receive money, and then of course you need to pay the money. So this type of cash flows are called financing cash flows. And of course, in real life, you can have a mixture of both of them and more ins and outs. So you can have, for example, you receive a loan, and then you need to start paying the loan for the credit, and then you receive another loan because you are growing faster, and then you need to pay larger, but you start also now receiving profits, etc. So you can have this type of behaviors. So this is a more generic cash flow. Now, what is interesting about the cash flows, guys, is that we use them as a tool for determining if a project is good or is bad. Okay. Now, remember that the cash flows that we have here, guys, represents two things. Can represent the profits before taxes or can represent the profits after taxes. So it's basically these numbers here represent already, what is left for you as a corporation or an investor. So you have already considered the revenues, you have considered the costs and expenses, and monetary and non-monetary expenses like depreciation, for example. And then after that, after you have paid your interest, et cetera, et cetera, et cetera, what is left before taxes or after taxes? That's the numbers that you're going to be representing in here. Got it? So it's basically how profitable is my business is what we're going to try to answer with a very simple technique that is called the net present value. Okay, so what is the net present value, guys? What you do is, and I will explain this in a very easy way with a very simple example. Okay. So net present value, net future value. We do both at the same time. So imagine, guys, that you invest $500 at year one. Then at year two, you receive $700, and at year three, you receive $900. Got it? So your question is, does this one here make sense? Is it good to invest this one here, invest in this project here? Well, the answer obviously is going to be depends. Depends on what? depends on what is your second best. What is your best alternative that is not this alternative? This is what is called the opportunity cost. Okay, let's call it OC. What is my opportunity cost, guys? It's simply, let's say, my best alternative, not this project. What the people call is my best second, but not necessarily is the second, you know, but it's my best alternative not being this project. Let's call project A. So I will call this project A. Right? So that's the definition. And opportunity cost, for example, and one of the things that you need to remember, guys, is that this opportunity cost should be realistic. Okay, should be something that you can get. It's not simply my imagination. I believe that I can get 50% per year. Okay, tell me where. Well, I don't know, but I believe. No, it's not a belief. It's something that you can really achieve. Okay, no, because if you determine a wrong opportunity cost, guys, you can be simply not doing good projects. Okay, so just for this example, guys, let's assume that my opportunity cost equals 10%. So what is the meaning of this one here is that if I don't do this project, I will have this $500 invested at 10%, right? For sure. So I will make this $500 is going to make 10% per period, right? Okay. So now let's talk a little about the net future value. Then it's easy to understand. So imagine the following. What is net future value, guys? It's simply moving all the cash flows to the future. Okay. So 700 and 900. So how do I move this 700 to the future? Well, 700 to the future implies that I put this money at my opportunity cost at 1.1 because my opportunity cost is 10%. So I obtain 770. So at the end of the 2 years, if I do this project, how much money do I have? So I will have 770 plus 900. So I will end up with $1,670. Right? So this is what I should have at the end of the second year. However, guys, remember that to achieve this 1,670, I have invested 500. So now just put yourself in the second condition. So forget about this cash flow and assume that you invest your $500 at your second best. So basically you invest here for 1 year and for 2 years. So you move this for 2 years. This is going to be then 500, 1.1 to the power 2. So let's do this. 500 times 1.1 squared. This is equal to 605. Okay, so now if you put all these things together, I will write here a negative number because this is an investment. Okay, so at the end of the second year, how much money you are going to keep with you? Indeed, you are going to keep 1,065. This value here, guys, is what is called the net future value. So this implies that, of course, you have produced more than what you have been producing with your initial investment at the opportunity cost. So if the net future value is larger than 0, so this implies that this project is better than your opportunity cost. Now, if we think that, you know, this is a valid analysis, however, the people in the industry don't use net future values. It's easy to understand for academia, but in real life, what we use is something that is called the net present value. So what is net present value? Well, we need to move all the funds from the future to the present. So this is called discounting. So what I need to do is I need to move my 700 to the present, and I need to move my 900 to the present. Okay. So how do I do that? Well, I simply move this one here. Discounting implies that you divide. So it's going to be 700 divided by 1.1. And moving the 900 in here is going to be simply 900 divided by 1.1 to the second power, because I'm doing one stop here and 2 stops here. So if I consider these the positive numbers and I subtract to this one here, is what is called the net present value. So it's going to be my investment at time 0, plus my cash flows discounted, plus 700 divided by 1.1, plus 900 divided by 1.1 squared. Okay. So let's do this. Let me see. So it's going to be 700 divided by 1.1. So this one here is going to be minus 500 plus 636.36 plus 900 divided by 1.1 squared This number here is 743.80. So my net present value then is going to be 636.36. I sum these two numbers. I sum this number plus this number minus this number. And then I obtain 880. I obtain 880.60. So this is my net present value. So what is the idea of net present value, guys? Is that discounted cash flows from the future to the present are larger than my original investment. So as soon as this number is larger than zero, so this implies good to the project. So the project produces more money than your best alternative, that is your opportunity cost. Right? So these are the rescission rules. And what is interesting, guys, is that these two are equivalent. Okay, so what do you mean by equivalent? Is that we are talking, if we talk about the net future value or we talk about the net present value, we indeed are talking about the exact same stuff. So how do I do that? Just take a look to what happens. This is a value in the future. Do you agree? This is a value 2 periods ahead. So what I can do is I can move this money to the present. 1065 divided 1.1 squared. Take a look to what happens. 1065 divided by 1.1 squared. We obtain 880.16. That is exactly, so this one here is my net future value. And this one here is my net present value, right? So they are equivalent. And you can do the reverse if you want. So if you want to move these two periods in the future, so 880.16, 1.1 squared, you're going to obtain 1065. That is your net future value. And see, these two are equivalent. And okay, so this is what we're going to do in Matlab. And I will show you how easy this works. Okay, now before going to there is another concept that is called the internal rate of return. The internal rate of return, or the IRR. So mathematically, guys, what is internal rate of return? Is the interest rate that makes the net present value to be equal to zero. Okay, so let's do that. I will not solve it by hand, but we're going to do this in Matlab. So I had here my 500, my 700, and my 900. Okay, so how do we compute the net present value? The net present value was minus 500 plus 700, 1 plus internal rate of return, plus 900. Remember, internal rate of return is simply an interest rate, internal rate of return to the power 2. And what I want is this to be 0. So we have one unknown, okay, one equation. So you can solve this one here. However, you're going to see you have a quadratic solution. So you're going to have 2 possible values of internal rate of return. Right? And we're going to find this using Matlab. Okay, so the decision rule for the internal rate of return is the following. If the internal rate of return is larger than the opportunity cost, then do the project. Okay? And this will make sense because imagine if this project produces 20%, okay? This is the average per period, 20%. So it produces 20% here, 20% here. This is an average. And your opportunity cost is only 10% per period. Obviously, you go with a higher one. If the internal rate of return is larger than opportunity cost, you take the process. Now, this is not a finance class, guys, but however, the internal rate of return has a lot of issues. Okay, it is a mathematical construct, so it works very nice if you have only one change on sign. So either you go this way, and then you have only positives, or you go positive and then you only have negatives. So the IRI works for these two guys. Okay, so no issue with them. However, guys, if you have cash flows, more realistic cash flows, you have here, then you start making money, then you do again another investment, and then you have another money, you start making money. So this one here, the internal rate of return, guys, can provide you misleading conclusions. Okay, so that's why what we do is we don't use internal rate of return. We use it if we have some references, not in these cash flows, but the one that never fails is indeed the net present value. So that's why the net present value is the one that really we care about. Okay, but in any case, this is one of the tools that we use, and you need to know how this works. Okay, so let's go into let's go to Matlab again. I will clean. If you want to clean, guys, you go home, clear workspace, okay, and then you go clear commands. Okay, so we clean my command window. And then what we can start doing then is, okay, so let's create a matrix that, let's call it a cash flow. I will call it cash flow. I will call it cash flow 1, just to make comparisons. Assume that my cash flow 1, guys, is, remember it was invest $500 and I will make $700 and $900. So this is the cash flow that we created just a couple of minutes ago, right? So if we want to compute, for example, the internal rate of return. So let's do the internal rate of return of cash flow 1. So it's going to be simply internal rate of return. It's very simple, IRR of this name here. And here we go. So my cash flow is 1.21. Okay, so this is 121%, guys. As soon as 121% is larger than my 10%, of course, it is a good idea to do this business instead of just putting your money at 10%. Make sense? Now, perhaps we have another cash flow. Okay, let's call it cash flow 2. And we'll just modify something. Imagine that this investment is good, the same investment, but now you have something like, perhaps something like that. Right? So you receive less in the first year, but you receive more in the second year. So we can compute also the internal rate of return of cash flow 2. So come here. It's 87%. So which one do you prefer based on the internal rate of return? Of course, you prefer the first cash flow. Right? So you prefer that the first investment, cash flow 1. Makes sense to you? So if you want to put these two in a single one, so I can say IRR projects. So we'll just for fun. What I can do is I can do, if you want to use the names already, you can use IRR cash flow 1. And if you want to see face to face, IRR cash flow 2, next to each other. So here we have the comparisons. Okay. So now, how do we compute the present values, the net present values? In order to compute the net present values, guys, let's create NPV cash flow 1. Let's do for 1 first. And this is going to be PV bar present value of what? Of cash flow 1. So let's modify the name here. Remember that caps and no caps are different. And the input that I need to have, guys, is my opportunity cost. My opportunity cost is 10%, so it's 0.1. Here we go. This is exactly what we got, remember? The cash flow that we did by hand, this is exactly what we got, 818. Okay, now just for fun, we can compute, instead of the net present value, the net future value. And the command instead of P is going to be simply BF. And then you simply run. And here we go, guys. This is our 1065 that we got in the future value. Okay, so let's do the same for cash flow 2. And then we put all these results in a single run. So cash flow 2, just to see what is our decision in terms of this one. And let's do the future value, cash flow 2. Oh. And then we have it. Okay. Okay, so now just for comparison, let's create a NPV, net present value, net future value, all, okay? Or how do I call the internal rate of returns? Projects, okay, so let's do projects. So just to create a matrix with this one here. Okay, so here what I want, for example, is I want to have the present values, you know, all in the same column, and the future values in the second column. So I can have this one here with my net future value of cash flow 1. And below, what I want to have is a net present value and net future value of cash flow 2. And you can organize this as you want, but let's do this in this way. Okay. So it's not L, it is NPV and F and NF. Here we go. So basically, this is the net present value of project 1, net present value of project 2. Obviously, guys, we need to select the one that has the highest net present value. So it also tells us that project 1 is the best. And also, if you want to use the net future values, as you can see, they don't contradict, they never contradict. This net future value is larger than this net future value. So remember, these are equivalent numbers, so you can use either. Make sense? Okay, so now another very easy financial application is something related to mortgages. Okay, let me show you what we are going to be doing. And then we do this in Matlab directly. So this is something that is called amortizations. Also called annuities. So what is the basic idea here, guys? Is that we have, imagine, this is easy to understand with a mortgage. So I have a principal, I need $500,000 for buying a home. And then I will have 30 years to make constant payments, for example. So I will monthly payments for 30 years. And then you have payments here. Right? And then how this works is, okay, so I have my principal. So what is my principal? Is the amount of money I will be asking. So this is called, this is my C0. I will have the period. So I said 30 years. The periodicity, how frequent you're going to pay. So let's do this monthly. So number of payments then. Number of payments is going to be simply 30 years times 12, and it's equal to 360 months, or 360 payments. And then, of course, you have the interest rate. So let's assume that the interest rate, guys, per year is 4%. This is annual rate. Okay, so if you have an annual rate, guys, you need to transform this annual rate, first of all, into monthly rate. So to transform the monthly rate, the formula is going to be 1.04. This is, I want 1 month. This is 1 year. So I want 1 over 12 minus 1. So if you do this, so it is 104 to the power 1 over 12. So let me see, 1.04 to the power 1 divided by 12 minus 1. So this is equal to 0. I will put this in percentages already, 0.3274%. So this is the percentage, the interest rate that you're going to pay per month. Okay? And with that, we're okay, guys. So with this one here, what we are going to be creating is a table, is the payment schedule, what is called. Okay, so how the payment schedule, it depends how do you put it, but normally the people do principal. Then you have, for example, the capital payments. you have the interest payments, and then you have the payment. Okay, so and that's what you have. So you started, imagine, let's do $250,000 here, and then you pay part of the payment. So part of this number here that we're going to compute here. So we need to compute here PMT. So what is PMT? We're gonna do that. Once you know this payment, you first compute the interest. So what is the interest that you're gonna compute here? For example, this one here, or this number here is going to be 250,000 times 0.3274%. So this is what you're going to pay here, okay? And this number here, so let's call this A and let's call this B. So this number here, simply, guys, is going to be A minus B. Is the residual, got it? And then once you have the first period, the first month, the second month is going to be, what is your principal? Is going to be $250,000 minus this number here. And then you continue creating your table, right? So at this table, of course, is going to go up to 360. And in 360, guys, what you need to be sure is that what is left here, it is exactly to what you pay in capital. So these two last numbers. So imagine I owe $2,000. So it should be equal to the capital payment that you do at the end of the period, okay? And this is what we are going to be building in a very simple way in using Matlab. Okay, so let's go to Matlab. Let's take a look at how this works. Okay, so let's define, guys, let's do my annual rate. Yeah, perhaps we can define all the values. The loan, we said is going to be $250,000. Good. Let's assume that my annual rate is 0.04. I want to compute what is my monthly rate. Monthly rate. And remember, my monthly rate is going to be 1 plus my annual rate to the power 1/12 minus 1. So here's the number that we got, 0.033. Now let's go to the number of periods. We said the number of periods is going to be 30 years times 12. So we have 360 payments. Okay, and then here what we are going to use is a command that is already built in Matlab. So let me find this, and so I can simply copy. And I will provide some explanation here for what we're doing. Okay, so when you call this one here, guys, is a built-in program already. Okay, someone created this program. In order to run this program, you need to enter this input. Monthly rate, I already computed monthly rate. Number of periods, I already computed number of periods. And the loan value, I already defined my loan to be $250,000. And once these inputs go into the program, it will compute something and it will return what you have to the left. You will have the principal, the interest, the balance, and the payment, right? So that's what it will have. Okay, so I will simply compute this one here. And I already have, if you want to see what do I have, just do whose. And you can see here, guys, I have the balance, the interest, the payment, the principal, etc. So we have all the components here. Now I will create my table, okay? So I will call it my amortization table. And in my amortization table, I have sorry, no, I don't want that. And I want to have here in my amortization table a very particular way of presenting that. I want the balance, this one. This one here, guys, comes in a single row. So that's why I will transpose that. Okay, so it comes in a row, comes this way. What I want is this way, vertical. So that's why I'm transposing. Then from the balance, I want the interest. So let's go the interest, also transposed. Then I want the principal. So how much is left? comma, how much is left, also transposed. And then I want my payment, just to see how much money I will be paying per month. You just click, it's going to be a kind of, oh, wait a second. So let's take a look to what is the dimension of, oh, here we have balance is 1 times 360, principal 1 times 360. The principal is also 160. The only problem that we have is payment. Payment is a 1 by 1. You see what is payment? Payment is a 1 times 1. If I want to create, if I want to make this conformable, what I need to do is I need to rep mat this one here. Do you agree? We did this last class. I will repeat rep mat. How many columns? How many rows? 360, because that's what I want, and 1 column. And then we have it. Remember, principal is 360, but what we're doing when we transpose is going to be 360 times 1. Okay, now we should have it. Oh yeah, we can change. Perhaps let's change the format, because here it is kind of weird. Let's do format. Let's call it bank. So this is one format that we have. If you want to know more about format, guys, just do help format. And you're going to have a huge description of what you can do. Right? So what I'm using is format bank somewhere. And then I can rerun my amortization table. And here we go. So this is what we have. So, oh, you know what? What we can do is we can add also just a vector of 1, 2, 360 transpose. So just to have that observation number. And then we can go to the first one here. Where is this one? Where is this one? So this is my table of payments. I will go to the first one. So this implies that the first payment, guys, once you pay the 818, so I have the balance. This is what you owe to the bank after you have paid 818 sorry, this is my interest, this is my principal. So I've paid in the first quote. My quote, okay, let me rewind. What you're going to be paying monthly, guys, is 1,183. From this 1,183, 818 goes as interest, and the difference of this number minus this number, so 1,183 minus 818 equals 364. This is what you're going to be amortizing. This is basically what this is going to be applied to your principal. So if your principal was 250 at the beginning, $250,000 minus 364 provides you 249, etc. Okay. So what is this number here? The 240, sorry, 200. What is that? It's 249, 269 minus 818. Sorry, 249, 635 minus 818 gives you this number. Got it? And now when you compute this from this payment, you are going to pay $817 in interest and $366 in principal. And then you continue going down. What was interesting, what I was telling to you guys, is that you need to be sure that what you owe at the end of the period is 0. Right? So basically, if you take a look to this number here versus this number here, so this is what you owe before, this is what you pay at the end. So what is your remaining balance? 0. Make sense? So this is the schedule, guys, that I was telling to you. Okay. Okay, so we have these two things, and net present value, net future value, internal rate of return. We have also the amortization table, so you know how to work with them. So I think it's time to go and perhaps do something about plots. Okay, so let's start with very simple plots. The simple XY plots. Let's create, first of all, let's do our sine cosine function. Just something very simple, just to create any graphs. So let's create X, and I want to do lean space. You remember that? And I want my lean space to go from 0 up to 2 times pi, and I want to have, let's say, 11 observations. Okay, so I just want to have 11 observations. And then what I will do is I will compute my y is going to be the sine of x. We just do semicolon. I don't want to be printing this stuff. And the easy way of plotting this one here, guys, is plot XY. And then if you do this plot, the first time it takes, I don't know why it takes a lot of time, but this is what we get. No. This one here. Okay. So if we do my plot, this is the plot of the sine function. Remember, sine of 0 is 0, sine of pi over pi half is equal to 1, etc. But it looks very robotic. It looks like, you know, flat here. It's not flat. And how do we create more smooth function? Well, the only thing that we need to do, guys, and that's why we have this linear space. So what we can do is linear space, instead of having 11 observations, what I can do is I can increase the grid, so I can have 100. Now, if you take a look to your sine and take a look to what happens with your plot, now the plot looks much nicer. You see? Okay. So what you can do, guys, is, for example, you can title. You can write a title. So just write title, sine function, for example. And then if you go to your graph, the title is going to appear here. So we can do a bunch of things. You can do legends. You can do a bunch of things that we're going to be learning soon. What is important, guys, is that normally what we do is when you create a plot in Matlab or R, you want this plot to be able to be imported into LaTeX or Word, you know, and then when you save for LaTeX or Word, guys, okay, just basically to present, what you normally select oh, sorry, I need to see, here we go. So the normal, you know, normally you are going to save this as an EPS. An EPS is fantastic for being imported into Word or to LaTeX. Okay, so if you want to have, just for presentation purposes, save it as EPS. Now, if you want to modify the figure in time, just save it as Fig. Because if you save this as Fig, Matlab later, if you want to open again the file, you simply call the graph, and the graph is going to be open in an editable way. So you can edit, you can change the names, you can change the axes, you can change whatever you want. Got it? So for printing, for presentation purposes, EPS, and to work with these ones here, to continue working with the graphs, Fig. So what I do normally, guys, I always save as Figs. And then if I'm really sure that I want to use this graph in my paper, I change it to EPS. Okay? Remember that if you do this EPS, you're never going to change it. EPS is a simple image. There's nothing more. Okay, so now let's do two things. And let's define Z equals cosine of X. I will not do this. Now, what I want to do is I want to present the sine and cosine all together. Okay, one way of doing this is, okay, I can create my plot always in XY process, XY, comma, XZ. So it always goes in pairs. It's gonna do, this is the first pair, and this is my second pair. All right, so if you click here, let's go to the graph. Oh. Let's go to the graph. And then you have it. You have the cosine function, and then you have the sine function. Okay, so perhaps you want to, you know, perhaps use, instead of red, you want to use crosses for the cosine function. So if you want to do that, you can do this one here. Take a look at what happens. So instead of having a line, now you have crosses. Now, if you want to know more about this function, guys, colors, etc., just do help plot, and you're gonna have a lot of useful help. You see, colors, B, green, red, magenta, etc. So it's very simple, and you can explore that. Now let's do another plot. Let's plot. You know, we have the sine and cosine, so let's plot Y and Z. Take a look to what happens when we plot Y and Z. We have the unit circle, guys. You see, -1 to 1, -1 to 1, -1 to 1. this is my famous unit circle that we always talk in trigonometric functions. Remember that? Now, as you have seen, guys, is that we have done one graph, but when I created this plot here, disappeared my previous plot. Correct? So what if I want to keep both plots? What you need to do is you need to open a new figure. So you simply type figure, and what it will do is we'll open an empty figure, and then you can plot here whatever you want. So I wanted to plot this one here, and then you are going to have two figures. I have this one here, and I have this figure here. So you can basically, you can see, you can work with both, etc. So in order to create multiple figures, every time that you want a new figure, you simply write figure, and then you start moving that. Make sense? Okay, so let's do a couple of other graphs. Normally, guys, we have some trigonometric properties. You remember that sine square, cosine square, sine square plus cosine square was equal to 1, correct? So let's take a look to that. So let's do a plot x, y, x, and this is going to be y to the power 2 plus c to the power 2. And I just don't want this. I just want perhaps green. Okay, so just for fun. Take a look. You see? X squared, y squared in the interval 0 to 2p is always 1. Indeed, any domain is going to be 1. Right? So this is cool. So there is another function, guys, that we use for seasonality, and you need to remember that. So 2 times sine of x times cosine of x is going to be equal to sine of 2x. Okay, we simply divide the dimension. So let's do this. So let's do the plot. Where is my this plot here? So I want to plot x and y. So this is my correct one. And then I want x with 2 times y, that is my sine, 2 times z. And then I want this guy to be something like that. Oh, sorry, this should be element by element. Remember, we don't have conformal matrices. So here we go, guys. You see, so the blue one is my simple sine function. If I want to reduce the frequency, I want to increase the frequency, what I do is simply do 2 times sine of theta or sine of x, that is equal to 2 times sine x cosine of x. And then you can do that. If you do 3 times, it's going to be thinner. If you do 100 times, it's going to be extremely thinner. Okay, so that's why we use this one here, basically, guys, to model seasonality. You know, we try to accommodate the sine function to the season or the cosine function to the season. Got it? Okay, so we have our graph, and then we can let's add something. So let's add a title. Okay, in title we can do sine 2x, just any title. I can do the x label, for example, if I want to write something in an x side. So I can say sine of x and cosine. No, sine of x and sine of 2x, something like that. The names don't matter. And I also can write y label. We can say what? Yeah, I can say values. So if you take a look to your graph, guys, you see values, x-axis, and the title. It's very straightforward. It is really easy to do. Okay. Now, what you can do also, guys, is you can add the grid. So if you do simply grid, take a look to what happens with your function. Appears this grid. Got it? What else from here? Yes. Okay. So what we can do is, guys, we can also. So let's take a look to. Let's create another figure. Remember, you need to create a figure, and let's put here my x, y, x, z. Let's do this one. So remember, this one here was my sine and cosine. Okay, and I want to write around here that this is the sine of function. So this is going to be more or less 2.5, 0.7, more or less the dimension 0.7 here in the y side, 0.7, and 2.5 more or less. So I want to write here that this is my sine function. So what I can use is I can use text, and then in text I need to put the x position, the dimension, and 0.7, and then what you want to write, sine of x, and take a look to what happens. Where's this one here? Here we go, sine of x. And then you can do the same for cosine of x. Is text is the x dimension, the y dimension, and what you want to write. Make sense? However, guys, there is another trick here that is called the g text. If you just type g text, I'm sorry, g text, and then you type what you want to write. I want to type cosine of x. Okay, so that's what I want, g text. Take a look to what's going to happen with the figure. So I'm working with this figure. So I already have written sine of x. I need to write now cosine of x. So just g text, and take a look, appears the figure and appears across. You see? So what you need to do is basically just put your cross wherever you want more or less to the function, then the name to appear. Just click there and appears there. Cosine of x. And so this is another command, g text. If you don't want to do that, if you want to do this manually, the text, x position, y position, and what you want to write. Got it? Now there is another. There are other commands also. For example, you have axis. No, an axis, guys, works always in this way. So axis. It has parentheses, and then you need to create a vector here. So it's always x min, x max, y min, y max. So I will do the same. X min, I want to be -1. Sorry. No, I think I said x min is going to be 0. For this particular, my x max is going to be 2 times pi, just to be coherent. My x min, my y min is going to be -1. And my y max is going to be 1. Okay, so I'm not modifying anything, but just let me modify so you can take a look to what happens. Take a look to what happens now. You see my axis? This goes from 0 to 2 pi, that's okay. But this one here now goes from -2 to 2. So this is the way you can modify the axis, the dimension of the axis. Okay. I think that with that, yeah, with that we should be okay. In very simple plot, we're going to do more plots in time, but let's move on doing perhaps some fancy plots. So let's go and let's do some amortization plots. Remember, we have created our tables already. I think amortization plots. Remember, we have our table. I think it was called amortization table. What was that? Yeah, this one here. Yeah, this one here. I prefer to work with this one here. Okay, and then what I will do is, I will plot the balance, the principal, and the interest. Okay, so, and I will use different colors, and I will do a couple of other things that you need to remember. So I will plot balance, and I want this to be color B, blue. And let me see. So this is my balance. Remember, it starts with a 250 more or less, and it ends in 0. Now, if I want to add something to the same figure, guys, okay, I don't want to create a new figure. I don't want this figure to be replaced by another figure. I want to add something more here. What you need to do is you need to write hold on. So this implies, hey, Matlab, please continue writing in this figure here. Okay? And what I will plot here is a cumulative sum. I'm summing my principal I want to see how much money I'm paying in principal. Of course, what I need to pay in principal is exactly $250,000, right? Otherwise, I cannot be paying more. I will do this one here. Cum sum is a cumulative sum of principal. So basically, what we are going to be doing is we're going to be, here we go, is this principal here is going to be this one here. The next one is going to be the sum of this plus this. So this plus this. The next one is going to be the sum of these three, etc. And of course, if you sum all these numbers here, you should obtain the amount of money that the bank lent you, 250. And it's going to be a linear function. So you take a look. Oh, where's, I haven't plot this one here. So you can see that the line is like that. So it starts low, but according to time, it goes growing faster than the interest rates. So the interest rates are going to be doing the reverse. The interest rates are going to be starting high and decreasing in time. And this is something that you can see in here. That you can see in here. So you see this here. The interest rates, sorry, the principal starts going up and the interest rates starts going down. Okay, so let's continue with my plot. So this is going to be, I think we call it interest. And I want this to be red. So here we go. Here we go. My principal, sorry, my balance, my principal, the dotted line, and my interest rates. Okay, and then from here I can write, guys, I can do the X label. So perhaps X label can be monthly payments. I can write my Y label as dollars, perhaps. Oops. This is not correct. Then I can have my grid. So remember the grid, or you can write grid on. If you want to disconnect the grid, go back to no lines, you simply grid. Then we can do title, for example, whatever you can imagine. Balance, perhaps cumulative principal, capital, principal and interest. Perhaps this can be my title. And also I can add my legend. So I can add a legend that says, you know, for example, outstanding balance. Outstanding balance. What was the next one? Cumulative principal. And the last one is going to be cumulative interest. Okay, remember that the name and not interest. Remember that the names, guys, so this must follow the way you have entered the graphs. Okay, so we started with balance, then we do principal, then we do the interest, and that's what we do, balance, principal, and interest. Okay, so let's take a look at what happens. You see? And then you can move, of course, this one here. If you want to put this one here, you can move as you want. And then you can save as an EPS if you want to present this in Word, in Excel, in Word or LaTeX, etc. Make sense to everyone? Okay, so let me stop this for a minute. Okay, so let's continue with doing other graphs that are important for finance. So let me clear. Where's my documents? Okay, so Matlab, guys, has some interesting building data as an example. So let's start loading. Let's get some pricing. Okay, so let's go IBM.dat. And let's do a high-low close charts. Okay, so let's do a high, low, and close charts. Okay, this is something that you're always gonna BC. So I have loaded this one here. Let's create, for example, my I and J. So this is going to be my columns and rows. And this is going to be the size of IBM. I call it, yeah. So if you type I, so we have 453 columns and rows, and J, we have six rows. Okay, so let's create a figure. Okay, it's open. And the command that we're going to use for doing the high-low is high-low. It's straightforward. What I want is IBM. And let's say I, so the total number of rows, minus 50. So just plot the last 50 observations up to I, not one I. And then I think it's the high, the second column. This is sorry, this is the high. Yes, now let's do the low. The low is the third column. And the close is the fourth column. And then just for the function, let's leave this open, nothing more. I just want to have this blue. Oh. Yeah, let me check. Okay, guys, apparently there is a problem with the IBM data. It only has high, low, and close, but the high-low command now is using open, high, low, and close. So a new data set I found online is Disney. So we can do load Disney Math. And then we can do the same. So if we can do the IJ. Oh yeah, let's take a look to who's first. So you can take a look. So Disney now has high, so it has the open, the high, the low, and the close. So these are the guys that we're going to be using. Okay, so let's take a look first to the dimensions. So I can do the dimensions of IJ as soon as all of them are the same, the dimensions of Disney low. And then what I will do is I will do my, just to make it clearer, I will do high low is my command. Disney open, so the first one should be the open, the second the high, the low, and the close. And what I'm doing, guys, is simply taking the last observations. Okay, and these are columns, so it's easy to handle. So if you just click here, this is what we get. So the high, of course, is the top, the low is the bottom, the close is the one that is in the right, and the open is the one that is in the left. So basically here I have an open and a close. So this is a bull market. And we're going to do a different candle graphs just to show you that too. Okay, so but this is basically the one that provides information. Remember, it's low, high, to the right is the close, to the left is the open. Okay. Let me move this one here. Let's use the same database, guys, to create candle plots. Okay. So what we do here, the command indeed is candle. Let's take a look. So hopefully we have the same. Let's take a look to this. I have this. Yeah, I have this, and I just will select. This is the time, so I will select 3. Hopefully this one has these ones here. 98 to assign to 4. Let's say 30, 98. So let's take a look. Oh, sorry. Need to do this. So I have candle. Okay, so it's this 331.98, 430.98. Okay, we have 1, 2, 3. Yes, here we go. Okay, so let's take a look at my graph. You see? So now you have your candle bars. And what is interesting, guys, is that if we have a bullish, so basically means that the open is smaller than the close. So we have white bars. And if we have a bearish, so means that the open is larger than the close. So we have the black or the blue bars. Right? So this is another way of seeing. So I have been bullish during this period. Then I have two days of bearish, and then I start going bullish again. So what we have here is we have the open, the high, the low, and the close, right? And dark blue is bearish periods, and kind of white bars are simply, or white candles are simply bullish periods, right? So it's another graph that is very easy, very useful, and perhaps we can do, or hopefully we can use the IBM data for that. So now let's load. I think I have. Let's load the IBM of that. And I will do the same IJ, but this one here is of IBM. Not sure if we have the same data, but let's try. And what I will do is, guys, I will create the Bollinger Bands. Okay, the Bollinger Bands basically are 2 standard deviations from the moving average up and 2 standard deviations from the moving average down. Okay, so and I will use, this is the IBM data has high, low, and close. So I will use the close. Right. So what I will do is a Bolling. There's Bolling. Then I will say IBM. You know, everything, comma 4. The fourth one is the one that has the closing. And my moving average is going to be 15. And I just need this one here. Here we go. You see? So I have my moving average, the red line, and 2 standard deviations above and below are my Bollinger Bands. So normally the Bollinger Bands guys tells you, okay, my mean is approaching to the upper bound versus my lower one. I have a trend here that is positive. I have a small downtrend, etc. I have a very strong downtrend. Right? So, and these are part of the technical indicators that we normally use in stock markets. What else we can start working here? Oh yeah, well, now let's go into something that is very useful for basically presentations. Let me change my screen again and save this one. And let's do something that is called the subplot. Okay. Sometimes, guys, when you are analyzing plots or graphs, you want to see all of them in a single page. Okay, and so basically a subplot is organized in a matrix form. So imagine that I want to do, okay, these are graphs. I want to do a subplot like this. So Matlab, as usual, guys, this is going to be the position, number of rows, and columns, as usual. Okay. So, and this is going to be position 1, position 2, position 3, position 4, 5, and 6. So that's the way Matlab works. It's 1, 2, 3, 4, 5, then goes down, continues, goes down, continues. Okay. So that's the basic idea, and that's what we are going to be working with Matlab right now. So let's go back to our share in Matlab. And let me clean all this part here. Okay, and let's create something very simple. So let's create again my x equals linspace. Yeah, let's do from 0 to times pi. What was next to, and let's do 30 observations on. I will create 4 graphs, independent graphs, 4 independent variables, sine of x. Let's see, z is going to be cosine of x. Oh, cosine of x. Let's create a, that is going to be 2 times sine of x times cosine of x. These are just examples, guys. And you know what? Perhaps let's do 2 times sine of x. Oh. Okay, and let's create AB. Let's do this sine of x. to the power 2 plus cosine of x to the power 2. So I have four, I have sine, it's element by element, remember that. And then I have four graphs, and I want to create basically a 2x2 subplot, okay? And what we are going to start doing now, guys, is simply creating the subplot. So I will define, the first time that you do the subplot is when you define the dimension. So it's going to be 2, 2. And then what you start doing is, okay, position. So the first position of my subplot, there is going to be a 2 times 2. So you have 2 rows and 2 columns. Position 1 is, let's do the plot, the plot of xy. Plot of xy. So this is x and sine of x. Okay, so we can add perhaps a title just to remember what is that. My title can be sine of x. Okay. Then we can do the subplot position 2. I can plot here. I can plot my x and c. So this is going to be my cosine, right? This is cosine. Now my subplot 3. So this goes the first down. Is going to be my, I call it a. And the function, and I can put the same name. This is what I'm representing in this graph. This is only text, so it's not really here. And my final plot, guys, is b. And what I want to do is this one here presents this one here. Okay, so if you take a look to the graph, oops, what happened? Oh, no, I forgot. So I have 1, 2, 3. So I need to do again the 3. So subplot 3. I forgot to do the, and subplot 3 is this one. I need to do another subplot. I need to do subplot position 4. This is this one here. Okay, now if you see your plot, I don't know if you have been seeing the graphs before. I'm really sorry, I don't really know, but now you can see. This is the 4 plots. This is 1, 1, 1, 2. This is position 1, position 2, position 3, position 4. So that's the way Matlab presents. I think this should be this one. This is what Matlab presents, the way Matlab presents the graph, the subplots. Okay, so this is extremely useful, and you know, it's easy to create. Okay. Now let's start working with another plot. So let's be sure first of all that I have a subplot 1, 1, 1. So this implies that I have a simple plot. Okay, so my graphs are going to be regular. So let's create, guys, for example, something that is called the bar plot. Okay, so how do we do that? Okay, so let's create first x to be a number that goes from minus 2.9, increasing by 0.1 or 0.2 up to 2.9. Okay, so I have a x. And what I will do is I will simply create y is an exponential function that is going to be exponent of minus x times x. Okay, and then what I will do my var, so just to show you how the var looks like, is xy. And then you can put, you know, of course, the titles, etc. And this is my var. Looks like a normal distribution, do you agree? And remember the normal distribution, the part, I'm writing this part here that represents the bell curve. Okay? So that's the way you create bar graphs. You can also create stairs, and in stairs, instead of bar, what you do is simply you type stairs. The same is xy. And the thing is that the difference is simply that you have a graph like that. Of course, something that is really important here, guys, is the histogram. So I will continue working the same. So I will create, so let's create X is going to be the same, just to be sure that I have X. And then I will create Y, that is going to be a random normal. So that's the command, rand n is random normal. And I will create 5,000 observations, one column. Okay, I don't want to print, so that's why I put XY. And what I will do, guys, is I will create a histogram of Y. Okay, please be attention here is Y for all the values of X. Okay, if you click here, your graph is going to be this one here. You see, looks like a normal distribution. We have hairy tails here because I've defined the values in this range. Now, if you want to remember the law of large numbers, guys, so the distribution is going to be much similar if we have more observations. So now assume that my Y is 50,000, and I do the histogram the same way. And what we are going to be noting, guys, is my histogram becomes more and more like a normal distribution. So this is basically my law of large numbers. If you have very few observations, then you start increasing the number of observations. Then if you go to the limit, so millions of observations, then at the end of the day, guys, what you have is basically the normal distribution. Right? Okay, so this is going to be for this class. What you need to do now is I will send you this assignment. The only part that you cannot do is the one that is 3D graphs. Okay, we're going to do that in next class. So please do these exercises here during the weekend, review this material, do the exercises, and you need to send me your results, and we're going to try to solve most of them during next class. This is my email. Please send it to me, and we continue talking on Monday. Okay? Thank you very much, and then we continue with classes next week. Thank you.